Alright, so today we're going to be doing Unit 5, which is Systems of Equations and Inequalities, Lesson 1, Solutions to Systems of Equations. So, solve systems of linear equations exactly and approximately, focusing on pairs of linear equations in two variables. And understand that the graph of an equation in two variables is the set of all of its solutions plotted in the coordinate plane, often forming a curve. Also could be a straight line. Okay? So,
wait, what is it?
We haven't filled anything in yet.
Oh.
So, systems of equations are where two or more equations with the same, what do you guys think? Solution.
Solution, man.
Yep. Two or more equations with the same solution. Now, there are two ways to kind of figure this out. You can either use a graph or algebra, okay? And graphically, the point xy is where the two lines what do you guys think? Intersect or cross. Okay, intersect is the same thing as where the lines cross. Like think of an intersection of a street, okay, where the two streets meet and they cross each other. And then algebraically is the point xy, which makes both equations true, okay, a true statement. So if you plug in x and y, your two sides of your equation will be equal to each other, okay? Now let's talk about the different types of solutions. So intersecting lines, okay, is where we have two lines that literally just intersect, okay? And this is their point of intersection right here. And their point of intersection is denoted by the coordinates x and y. And they have one solution, which is that intersection, okay, x and y. Now the next type that we have are what we call parallel lines. Okay, parallel lines. Now, do parallel lines ever intersect each other?
No.
No, they never intersect, so do they have a solution?
Yes. No.
No solution. So these have no solution, and you can either write this as an empty set or you can write this 0 with a slash through, okay? That means there's no solution. And then, if I take a line and I draw it, and then I draw a line directly over that line, okay? Those are the same two lines, just plotted over each other, right? And if you plot each other directly over each other, right, that means they share all of the same solutions. Every point on those two lines is the same as the point on the other line. Okay, they share all solutions. So infinite solutions, this is the infinity symbol. It's like an 8 on its side, okay? So the first type of solving systems that we're going to be talking about is going to be solving systems of equations by graphing, okay? So in order to solve systems of equations by graphing, you need to rewrite them in what we call slope-intercept form. Slope-intercept form. And that form looks like this, y equals mx plus b. You guys remember that, y equals mx plus b from Algebra 1? Well, maybe you're going to like it this time around. Have a positive, open mind, okay? Then we're going to graph the lines, and then we're going to identify the solutions or where the two lines intersect or cross. I keep wanting to write intersect. Intersect or cross.
Wait, is it not intersect?
It's intersect. Intercept is, this is intercept. This is intersect.
Okay, I was about to say you did it wrong then. What?
No, it's two different things. They're just similar words. Intercept is where we hit an axis, like an x-intercept or y-intercept. Intersection is any point where two things intersect. Somebody knock?
No.
Oh, okay. All right. So now we're going to go about actually finding this, okay? We're going to wait because I can't with that. So we look at our two equations and we determine if these are in slope-intercept form. So I'll zoom in here so we can get a better look at it. So slope-intercept form is y equals mx plus b. The m indicates a slope, and the b indicates the y-intercept, okay? So the slope is always the coefficient of x. So if there is no number in front of x, what is the implied coefficient? 1. So these are both in slope-intercept form, so we're going to go ahead and graph them. I'm going to graph the first one in red, and I will graph the second one in green so that you can keep them separate. So let's go ahead and graph the first one. So the first thing you always graph is the y-intercept, which is the number at the end here. And that always goes on your y-axis. So you're going to plot -8. So 1, 2, 3, 4, 5, 6, 7, 8 down here. Now, from that -8, you're going to determine the slope. So the slope here is 1. So whenever you take a slope, you put it over 1. So 1 over 1, which means that's my rise and my run. My rise and my run. So this goes up 1 over 1. Up 1 over 1. Up 1 over 1. And you guys you take your test at home, so you can use Desmos to check your graph as well.
Wait, what test?
Whenever you have a test in my class on this.
Oh.
So once you have that, a general idea of what your line looks like, you're going to go ahead and graph it. So it's going to look like this.
There's some, like, I cannot draw a straight line.
I know it's hard.
Oh my God, I got all these things to help me do it, but I can't.
So now we're going to plot our other line. So does anybody have any questions about how we plotted this line?
Oh, man.
All right, so the next line, we first look at its y-intercept. What's the y-intercept of the one in the green here?
The -2.
That's the slope.
Isn't that B?
B is the one at the end, yeah.
So why did you say on the Y?
It is. It's the y-intercept. It's also known.
The Y-intercept?
It's called B.
Oh.
So my y-intercept is at 1 right here, okay? So this is my y-intercept. And then this is my what?
2 over 1.
Good. This is my slope.
Slope, yeah.
So you rewrite your slope as a fraction. -2 over 1. Okay? Come get your notes. That whole thing. Everything, yeah. You're going to need all of it.
Everything?
Yep, that's for the whole day.
That's so tough.
No. Like I already made it all, like you're all set. I just put it all together for you. The whole entire thing is what's yours. So this is my slope, which is -2 over 1. So we go down 2 units, 1, 2, and over 1. Down 2 over 1. And you just repeat this until you form a line. And it'll look like this.
Well, no, well, yo, I did it wrong. That's not gonna
You have to cross it out then. I don't know what to tell you. So it looks like this. You guys see that? Okay. So now we find where they intersect. So do you guys all see where these two lines intersect right here?
Yeah.
So what's the coordinates of that intersection? 1, 2, 3. 3, comma 1, 2, 3, 4, 5. -5, right? 3, -5 would be our intersection point.
That was insane, man. Look at all that work we did.
It wasn't that much work.
Just to get one answer.
So does anybody have any questions? Alright. So number 2, we're gonna graph both of these, okay? I'm gonna graph the first one in like this dark green color, and I'll graph the second one in this red so you can follow along with me. So, what is the y-intercept on the first one, guys? Which one's the y-intercept on 2? The 1/2 or the 9?
The 9.
The 9. So you go up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 right here. So you plot the 9. This is your y-intercept, meaning it's on the y-axis, okay? Now you look at the slope. So your slope is always rise over run. You guys remember that? Rise over run. So you're going to go from here and go up 1 unit and over 2 units. Now the problem is you're going to start going off the graph on this one. You guys see that? So what you can do is you can actually go the exact opposite on both. You could go down and to the left, and that's okay as long as you go opposite on both. So you can kind of see how you just continue that line basically out this other direction, like that. And once you have done all of that, you're just going to connect it. It's just going to be one big line like this, just like that. And then you're going to graph the other one. So what is the y-intercept on this one? If this one's 9, then this one is 6. Very good. So this is your y-intercept, which is at 6, and we're going to plot it. 1, 2, 3, 4, 5, 6. And if we don't have a coefficient here, what is this going to be in front of the x? Whenever you don't have one, what's it going to be?
1.
1. So this is negative 1. You take your slope and you put it over 1. So I'm going down 1 over 1. Down 1 over 1, and you just continue this process like that. Until you kind of see that intersection point. You guys see that intersection point? I'm going to do it in magenta because, yeah, close enough. You guys get the idea. So that's what it looks like. Okay? So once you found that, you have to find the intersection of the two, okay? So this is their intersection, obviously you guys see that. And what's the coordinates of the intersection? -2 comma what? 1, 2, 3, 4, 5, 6, 7, 8. -2, 8, right? I'm just finding the intersection. Would you guys agree that's -2, 8?
Yes.
Good. So far so good? Does it make sense so far to you guys?
Ma'am.
Perfect. Okay. All right, moving on. Let's go ahead and fill in the rest of these blanks here. So, I should zoom out, huh? That's too close. A method of solving systems of equations by, we call it substituting. By substituting equations within one another. So the first step is to solve one equation for x or y. So sometimes that's already going to be done for you, but sometimes you have to do it yourself. So you get x or y by itself in one of the equations. And then number 2 says substitute this expression into the other equation and solve for the other variable. And once you do that, you're going to plug in or substitute your answer into the revised equation from step 1 and solve for the last variable. So in my opinion, I think it's a lot easier to just go ahead and show you how this works instead of like the words. I mean, it's a good reference point afterwards, but you know, it makes more sense when you actually just see it. So, all right, let's do that. So we're going to solve systems by substitution. So when you have two equations equal to the same variable, okay? So think about it this way. If you have two friends and they're both the same age as you, right? You guys all three are the same age, equal ages, right? So it's the same situation here. If they're both equal to y, they must both be equal to each other, right? So if you ever have two that are equal to y, you can just set the two equal to each other, okay? And I'm going to ask you a question like that on the test, so just be aware of it. So you set them both equal to each other. If they're both equal to y, they're both equal to each other. Once you do that, you're just going to solve for x, however you need to do so. So I'm going to do that by adding 1 to both sides. That gives me 4x equals 2x minus 4. My goal is to then get x to one side and get all my numbers to another side, okay? So I'm going to subtract 2x on both sides, which will get all the x's to the other side. This cancels out, and I'm left with 2x is equal to negative 4. And then what's my last step to solve for x?
You divide.
Good, divide by 2 on both sides, which gives me x equals what? Negative 2. So the answer to your system is going to be negative 2 comma something. Now, how do you find the other coordinate? Well, you take the negative 2 and plug it back into one of the original equations. So you get to pick which one you want to do. You guys want to do the first one or the second? Just pick, first, second. First. We're going to plug into the first. So we have y equals 4 times, we plug in that x that we just found. So I just took the first equation, somebody not? And I just replaced x with what we just found, which is negative 2. Come on up, I'll just get your notes. So then from here, we're just going to solve for y. So what's 4 times negative 2?
Negative 8.
Good. And what's negative 8 minus 1? Negative 9. So my answer here is negative 2 comma negative 9. And you could check your work by plugging that back into both equations and ensuring that they equal each other, okay? So that's how you do that. Now the next one we're going to look at right here. So our first step is to always set one equal to one variable. So is one of these equal to one variable? One of these equations? Which one?
The y equals 6x.
Good. So if you have one of them equal to one of the variables, you're going to take whatever it is equal to, and you're going to plug that into the other equation. So since it's equal to y, I can replace all of my y's with 6x in the other equation. So that's going to become 2x plus 3 times 6x is equal to negative 20, just like that. So you're just replacing your y with whatever y is equal to. Do you guys all see that? I substituted this into the equation right here. So it's just this equation, but I replaced the y with 6x. You guys with me on that? Now you just solve this. So this is 2x plus, what's 3 times 6x? Three times 6? 3 times 6?
8 times 6.
18. 18x equals negative 20. What's 2x plus 18x? Not 8.
20x.
20x. So 20x is equal to negative 20. So what times 20 would give me negative 20?
1. 0.
1.
Negative 1.
Negative 1.
Divide both sides by 20. Negative 20 divided by 20 is negative 1. So my coordinate is negative 1 comma something. Well, how do I find the other something? I plug negative 1 back into one of the other equations. So which equation would be easier to plug back into, the first or the second?
Second.
This one's way more work, right? This one's a lot easier.
Uh,
So I'm just going to plug in my x into this one. So this is y equals negative 6. Just like that. And that's your final answer.
oh my gosh. Are we done this?
Yes, can you scroll to the number 3?
Sure.
I'll cover that in green real quick.
So that's what you guys are working on. So I went through this, but if you guys came in late, so let me explain it one more time. So I just gave you guys all of your stuff today in one because I had to print it like that. So you guys had your notes, which is the first page. Now you guys are working on the practice assignment, which is due today, okay? And this one here, we're going to continue working on today and Wednesday. So you have today and Wednesday to work on. So we'll do more notes on Wednesday, then you'll have time at the end for this. So you guys get the idea? All right. Good luck.
Let me screen scroll up a little bit more.
Do what?
Can you
Scroll up a little bit more.
So ultimately, these two are going to be two different submissions on eCampus. Really, what I want to make sure you know.